All right, I think we can get started. My name is Hugh Peterson, our product manager for Standard Imaging, and today we're going to be talking about our DoseView 3D Water Phantom and annual QA and commissioning, etc. So we like to say it takes some of the hassle out of your annual QA. You can optimize with ease with the Water Phantom. We try to uncomplicate things as far as our operation of the setup of the tank, but also with the software itself for doing your scans, your profiles, your depth measurements, etc. So let's go ahead. So basically, obviously your water phantom objectives are pretty straightforward. Your acceptance testing, you're checking your treatment system versus the manufacturer's stated specs, commissioning those linacs, checking all your energies, your field sizes, your wedges, etc. You're getting all that beam data that you collect into your treatment planning systems. Then, of course, there's your annual and your monthly QA. Obviously, you probably don't use the 3D tank for your monthly, but for your annual QA, doing those yearly checks, the water phantoms come into play pretty significantly. But our software also has capabilities for that TG142, TG51, and TRS398 monthly checks as well. If you're using our 1D tank, that's also incorporated into our software. And of course, you also have those periodic checks of beam quality as they're needed. Possibly you had a PM of your linac, or you had the machine went down and you want to make sure that everything is still correct with your beam modeling and stuff like that. Gives you the ability to do those periodic checks also. So what makes a good water phantom? Obviously you want highly accurate and repeatable positions. And that's something we've taken pains to produce with our water phantom. Everything is very accurate with our water phantom to produce those high quality raw measurements. Keeps you from having to do a lot of post scan processing, so it makes things a little easier, and a little more time saving as far as doing your measurements and doing that analyzation of the scans. You want reliable hardware year after year. Like I mentioned, it's something you might not use every day. Obviously, you don't want to use it every day because it's quite realistically, it's using a 3D water phantom is not something you would do every day. So you want easy setup and you want easy use, since it may only be used on that annual basis in a best case scenario. And you also want that flexibility and compatibility, the ability to use any type of different detectors, different protocols, whether it's AAPM or IAEA or possibly other regional protocols that are called for. You want the ability to have versatility for all different types of treatment planning system formats for import into the treatment planning system of the various linac manufacturers, things like that. So that's something that you're looking for in a water phantom, and quite honestly, the DoseView 3D system does that very well. Has the ability to incorporate just about all those components and factors. But kind of getting into the nuts and bolts of it, if you will. We take, like I mentioned, we take great pains into producing a phantom that is very accurate and gives you good repeatability time and time again over the course of the age of the and use of the phantom. We use a heavy gauge extruded aluminum frame that maximizes rigidity. It simplifies the setup and it maintains that reproducibility. We use redundant motors, so there's accurate and repeatable movement. The motors are calibrated together, so they are in lockstep essentially when they are running along the mechanism and the robot, as we call it. The system allows for a very precise 3-point and quick leveling with a 3-point leveling system. And even before the system goes out the door, it's tested on an industrial coordinate system. We measure at 39 different points to check different accuracies and the movement of the robot and the scanning arms. And then also we do a 24-hour burn-in just to make sure that the robot motors are all working correctly and are in alignment and sync with each other. So all the design elements are purposed to get you scanning quickly and, more importantly, accurately within the scanning of the profiles and the depth measurements. Another few things we'd like to say, it's in the details. You know, these are kind of convenience components, but it's a nice addition to the water fan to again make things quick and easy. The water tank and the frame are mechanically secured together, so that ensures a long-term integrity and reproducibility. Something small but is very significant is we got what we call an advanced suction drain to minimize water in the tank after draining. So it basically has a moat system around the bottom of the tank that allows you to draw out the majority of the water, so your arms aren't sitting in residual water. So it reduces mineralization and oxidation of those armatures. And then we also provide a fully integrated lift and reservoir cart with a precision leveling platform, which I'll kind of touch on in the next slide. But we do also have an optional lift cart that is it's lift only. It does not have the reservoir, so if you have water availability in the vault, you can utilize that. But we give you both options, and both do incorporate that precision positioning platform. And again, all those design elements are purposed in this case for convenience and ease of use. So a little touch on the precision positioning platform. That's hard to say. It has a coarse rotational adjustments in the 45 and the 90s, so you can lock it into place at 45s for diagonal scans for doing very large fields. It also has 3 fine adjustment levers for the X and Y position to go very fine movement in the X and Y, and also a rotational. So once you get the coarse adjustment underneath, you can fine tune and adjust the position of the crosshair that's etched in the bottom to match your center cross hair of the light field, and make that quick and easy setup there. So it's something that we kind of take pains to do. Again, is giving you that precision to set this tank up accordingly. Versatile LINAC QA, not only your C-arm conventional LINACs, but the Water Phantom is small enough to fit in the Halcyon and Ethos units to give you QA of that system there. So it's we redeveloped what we call a second generation hardware, the second generation Water Phantom a couple years back, probably 3-4 years ago. We released Gen 2. It's got a lower profile, it's a compact design, it's got improved rigidity over the first generation, and it also gives you that Ethos and Halcyon compatibility. Another nice little feature we've got, small but mighty, is the brass alignment cap. You can use this on your A28 scanning chamber to help center and align the probe within the bore. Since there's no internal lasers on the Halcyon unit, it gives you the ability to use the MV imaging system within the Halcyon for localizing and accurately positioning the chamber at origin. Some other hardware features, and we've got a very intuitive wireless pendant, simple setup and system configuration. You're not tethered to the tank, so you can walk around as you're doing your setup for your origin and your runouts. Gives you the ability to kind of track and watch that. It's got an onboard display that shows that probe position at all times. 3 touch button probe speeds, so you can move it in a fast, slow, or 0.1 millimeter step mode to kind of move the chamber accordingly when you're doing your runouts quickly, but also gives you that accurate 1 millimeter, 0.1 millimeter step to position it at the origin very quickly and easily. And then we also, for convenience, have a bias switch on the pendant as well. It's a small thing, but a lot of times if you walk out of the bunker and turn your bias on at the console with the software, and then realize you need to change something, you can walk into the bunker. If you forget to turn the bias off at the console, you can turn it off at the tank itself or with the pendant in the vault. So it saves you that trip in and out. Additionally, we have wired or wireless connectivity to the PC. So we include basically it's a Zigbee type radio transmitter receiver to have wireless connection to the PC, so you don't have all these extraneous cables, to connect to the system. Gives you a little more, just a little versatility and convenience to set up. Something that I mentioned early on, we've got a long history with electrometers, and that doesn't change for the DoseView. We developed our 3D DoseView 3D electrometer to be suited well for scanning. It's a charge digitizing electrometer for that high-speed acquisition. It's got a very fine 10 femtocoulomb resolution. It's got dual polarity bias voltages and independent bias voltages as well. So if you're using, say, a diode and an ion chamber for reference and field measurements, you can independently set those accordingly, turning them on and off depending on what your needs are. If you're using a diode for your field detector, obviously you don't use bias on that, but you would use it on a chamber for your reference, so you can turn those off independently as well, on or off independently as well, I should say. Something that's very unique to our system is our setup. We have a quick leveling and detector alignment jig for setup. It's very quick and easy. Like I mentioned, we have a 3-point leveling system. And this leveling jig you see kind of in the drawing on the left, the drawings I should say, gives you the ability to kind of set that to water level, do your runouts, kind of track how things are setting up, and quickly and easily adjust accordingly to those. You see there's a X crosshair on the tip of it, and you can track that along your water level to make sure that it's level across. Makes things very easy to adjust and set up. And then from there, once that's set up and set at origin correctly, we've got the detector alignment jig that allows you to set your chamber on there, place it accordingly to that the center of the collecting volume, as you see there with the line on the aluminum jig. Then you just take that chamber holder, replace that on the chamber carriage. Pull off the alignment jig, put on the chamber holder, and it places that chamber right at that tank origin and isocenter. So you can do that with any number of chambers without having to reset the origin or the isocenter. And you can see the system comes with a number of different chamber holders. It comes one specifically for our 828, which are our scanning specific chambers. But then also we have a universal one if you want to use a farmer chamber or a larger volume chamber. There's some different micro chamber holders as well. And then of course you can see on the right there's 3 different parallel plate ion chamber holders as well. One for the roost chamber, one for the Marcus chamber, and then one for our A10, which is our Marcus type chamber that we offer as well with our X-Radon line of ion chambers. Another nice time-saving feature to get you scanning quickly. Once you kind of set your origin, we actually have a fine beam center, which will move the chamber in at any depth. You can set the depth accordingly, and then you can run the chamber in both crossplane and in plane. It will find basically find the 50% lines of the field, and then once it does that in the crossplane and in plane, it will give you suggested crossplane shifts and in plane shifts, which allow you to automatically shift that origin to the center of that found crosshair. Usually, like I said, you can get it very close, but it's usually within decimals of millimeters for adjustment, and that will do that automatically. So it just kind of takes some of that hassle out, and like I said, optimize things with ease. One thing we're looking to release in the next version of the software is actually a skew correction, which is very similar to the locate beam center, but it allows you to do it at 2 depths automatically. So you can say you want to do it at the Dmax depth, and then you want to drop it down, say to 10 or 15 or 20 centimeters. Do it again, and then it will allow you to kind of adjust accordingly. It'll find the center point between those 2 depths, and will set that origin there. So we'll actually account for any skew when you're doing your depth measurements. So it's just a matter of giving you more accuracy for the setup. And that's coming in version 3.3 in the near future. Our detectors and our ion chambers. This is something we've been have been working on and supplying for the last 30 plus years as well. We've got our X-ray and A28 scanning chambers, or 0.125 cc volume, and there's a spherical collecting volume. So if you're doing cross-plane and in-plane, you get very similar results as compared to some of the chambers out there that have a elliptical collecting volume. A few other things about our ion chambers. We've got a whole host of different size ion chambers, from our 0.6 cc farmer chambers to our scanning chambers, down to our micro chambers. We've got our A26 micro chamber, which is 0.015 cc, and that gives you, basically, it's one of the only reference-based I lost my train of thought, I apologize. Small volume chambers, stereotactic chambers out there. So it's actually is calibratable and it is considered a reference class ion chamber. All our ion chambers are made of homogeneous Schranke conductive plastic, and then that's in the collector guard and shell. So there's no high Z materials to perturb the beam. There's no metal collectors, as you see with a lot of the other chambers using copper for the collectors. Making it out of that plastic is much more robust than say a graphite thimble. It's a much stronger material, and because of that, we offer a 5-year warranty on all our ion chambers. And then we also have a number of different types of detectors. We've got our D1V and D1H diodes. We've got our scintillators, our W2 scintillators. You see there is a 1 millimeter by 1 millimeter scintillator, so for measuring very small fields. And you can plug that into the scanning electrometer of the DoseView and utilize that for your small field measurements. Moving on from the hardware now to the software. A few years back, we had basically started from the ground up, rewrote the software because we had a lot of feedback from users that they wanted a software that was simplified. It's got all the functionalities, all the capabilities, but they want an easier interface, and they want things to be kind of at their fingertips. So basically we built it from the ground up on suggestions from users to have more intuitive menus for not only scan queue setup and measurement, but also for the analysis. So everything is easy, right to left, top to bottom navigation like you're used to in a Windows environment. We like to say that we have no hidden features. Everything is kind of at your fingertips. You don't have to go digging in different folders, or you don't have to go digging in different tabs, things like that for your different functionalities within the software. And as I kind of mentioned, just briefly, we're fully integrated not only for the DoseView 3D Phantom, but then also for our 1D Phantoms as well. And you can enter into either side of the software for the 3D or the 1D for measurements. That being said, I'm going to kind of jump into the software now and just kind of give you a quick once-over, a quick view of the software, and then we'll kind of get you on your way. So I appreciate the time you're spending with us today, and I will try and keep it brief and move it along, get you back to your day. So, but basically, there's three components to the DoseView software. And that's either the DoseView 3D side or the 1D side. There's your setup, there's your measure, and your analyze. Setup is pretty straightforward. You have your clinics and machines. So I've got my clinics here. I've got my demo clinic, and then I have my demo data LINAC and my data demo LINAC. I've got a couple different energies. You can add those energies very easily. You can add machines. You can add clinics very easily. So if you're a consulting physicist and you have this on your laptop that you might take from site to site, you can set those clinics up very easily along with those specific LINACs at the various sites. Detectors, very straightforward as well. You have a library of detectors here. You can add very easily your types of detectors, the name of the detector, the manufacturer. We try to stay vendor neutral here, so we realize that you may have detectors and ion chambers from other manufacturers. We prefer you use ours, but it is what it is, and you can certainly enter in your IBA chambers, your PDW chambers, even your Sun nuclear chambers if you have those, or other manufacturers as well, going back to some of the other manufacturers. Enter in your model, enter in your type, whether it's a cylindrical or parallel plate or a diode, or another type with bias or another type without bias. And this is kind of a key point, is that if you enter in a diode and you go to the measure page, and I'll show you that in a minute, but if you are using a detector that does not use bias, say a diode or the other with no bias, as a safety feature, the software will not let you turn the bias on. So you can avoid damage to your detector. You can avoid damage to the electrometer by extraneously turning on the bias if it's a detector that does not use bias. So that's kind of what you've got there. It gives you the ability to choose your different specifics. You can enter in your inner diameter of the chamber, and that's for later on when you do your dose conversions, serial number comment, etc. So it's very very straightforward to enter those in. And then you can have your list of different chambers here. I'm going to hop over scan cues real quickly, and I'll go back to that in a second. For preferences, this is just the types of delimiters you might have for your CSV files for export, whether your separators are commas or semicolons, etc. Same with decimal separators. Here in the States, we typically use a period. I know some other regions in the world use commas to separate their decimals, so we give you that functionality, as well as choosing different time and date formats as well. Now, jumping into the scan cues, you have all the different scan cues that you have set up in the past, but they're very easy. This is kind of one of the nice features of the software. It allows you to very easily, very quickly set up the cues. And really, once you have things set up, whether it's Clinica's machine, the detectors, and the scan cues, you really don't even have to go back to set up. Again, it's you can go right into measure when you're doing your annual scans or your commissioning, what have you. But basically, it's pretty straightforward. You can see here I've got 4 categories, and they're marked as not set. So all I need to do, give it a name. So something along that line, whatever you want to call it. Give it a descriptor. I can choose my medium, whether I'm going to measure in water or air. My modality, whether it's MV, filter-free scanning, or electrons. My field definition components, whether it's JAWS or it's MLCs. I can also do SRS cones, and that will allow you to choose your diameters. And if there's any modifiers, if you're using a wedge or using any kind of electron cutouts, things like that. But you'll see once I finish this gets marked as complete, so it's easy to see kind of where you're at. I only want to do 6 MV. I can add or delete various energies depending on the LINAC I have. My field sizes, I can enter them in manually here, and they will populate up here. For this case, I want to do maybe a 10 by 10 and a 5 by 5. I can do circular ones, like I mentioned, for SRS cones, and those are all marked complete. And then I can choose my scan types. And my scan types, I want to do cross plane, in plane, and depth. You'll see once I choose those, you get a couple more subjects here. I've got my depths, so I want to choose my depths. So for 6 MV, I want to do some at Dmax and maybe some at 10. My CAX offsets, I can set those accordingly. If I want to do just central axis, I can choose those. I can set my different axis if I want to do maybe 30 by 30, or 25 by 25 or 5 by 5. I can choose those as well and add those. And then lastly, I've got scan mode. I am ready to scan now. You can see everything is complete, but I can go to my scan mode. And this gives me a few different things I can choose as well. I can choose either step scanning or continuous. I can choose either single zones or multiple zones. And the multiple zones give me the ability to have a little bit higher resolution in the high gradient regions like the penumbra. So if I want to do, say, my flat region and my tails at 15 millimeters per second, but I wanted some higher resolution in my penumbra region, I can set that at 5, or I can set that whatever I want. And I can also choose my zone sizes. So if I have a little bit wider outer zone, or a little wider in my inner zone, I can change those accordingly. And then I can also choose my overscan difference distance as well, either in centimeters or percentage of my full width half max. So that's kind of where we're at there. Same with depths. I can choose step or continuous there. If I have a point or a pathway that won't necessarily hit Dmax, I can force a point to measurement at Dmax. I can choose similarly single zone or multiple zones if I want a higher resolution in the Dmax region. I've got that. I can change my zone sizes, and then I can choose my zone end as well. But now I'm all ready to go, and you can see here with the scans I've chosen, my 6 MV scans and a couple of different field sizes. I've got 10 different scans I need to do or will be doing. I can go ahead and save that, and you'll see now the test set scan 6 MV is here. I can do if I wanted to maybe use that same set of parameters for, say, 10 MV, I can copy that, and I can then I can edit it, and I can do batch changes to that to make a different plan. I've got a lot of different things I can do. I can export my scan sets to a DoseView format, so I can bring those to another PC. Like I said, if you're a consulting physicist and you might have some different setups at different centers, you can easily export that and import them into those other PCs. But that's kind of all you need to do for the setup, and you're all set to go. Measure. You can choose your machine. You can choose your dose rate and your settling times and your sample times. I can connect my water phantom. Nice thing too, because you're not using it every day and you're not using it, best case scenario annually, you can choose demo mode, connect to that, initialize it, and then you can kind of play around with the software as if it was connected to a water phantom. Just kind of maybe kind of reacquaint yourself with the software. If you have scanning to do over a weekend or something, and maybe you just want to kind of refamiliarize yourself, you can do that very easily. I can choose my detectors. In this case, I'm going to use my A28s, which are my scanning chambers. I've got my 1 and my 2 for field and reference. I have the ability to turn off not use a reference chamber. I can set my electrometer accordingly. So in this case, I want to have 300 volts bias to my field and my reference. Shows you there what's being measured. I can zero my electrometer from here. I can choose my position, so I can move, I can go to origin, I can set my origin from here, I can go to a specific position if I want. Here's my locate beam center, and basically, like I mentioned, I have my cross plane and in plane. I can go to a specific depth, I can hit locate beam center, it'll do those runs to the 50% line, then give my cross plane and in plane shifts, allow me to shift that origin very easily, and then I'm ready to go. As I mentioned, we're adding skew correction. This is a beta version of this software, so I do have the ability to do that on this, but this is very similar to the locate beam center, but you're doing it at 2 different depths. And then it basically shows you your cross plane shift at your first depth and a cross plane and in plane shift at your second depth. And then it will show you a cross plane and in plane skew in degrees. And it will give you the option to do a shift magnitude for your in-plane and cross-plane too, and then that will basically give you that skew correction for your depth measurements. So pretty straightforward. A nice little easy tool to use for setting things up. And then lastly is just phantom orientation, and that's just how the phantom is going under the Linux. So this gray bar here, That notes what we call our MCU, which is our motion control unit. You know, if I come in from the left side, I'm coming from the front, it kind of just dictates what is considered X, what is considered Y. So it's just, you know, geometrically giving you the correct alignment for your cross plane and in plane. So other than that, you're ready to go. So that's all you need to do for the hardware side. My scan queue, I'm going to grab my my scan queue here. You'll see it just tells me to check my dose rates, make sure they're correct. Click that, OK. And then you see here, you kind of see barred places. I've got one energy, but I've got two different field sizes. So they kind of separate them and give you an easy visual of how your different scan parameters are separated. So I've got my 10 by 10s here in blue, and then I've got my 5 by 5s here in white. Again, I can zero my electrometer wherever I want. I can normalize from here. If I want to go to my my depth accordingly, I want to normalize there and close that, and then I can start my scans. And you'll see here, these are demo scans, obviously, kind of simulating a measurement. You'll see here the active scan is shown in green and the percentage of completion. And then when these go down, you actually get a dialog box saying, hey, and an audible chime saying you need to change something. In this case, I need to change my field size. But you can see my scans are moving along. As they move, I can go into my analyze page. My analyze page here, I've got a few scans that are already pre-selected. But you can go ahead and, while your scans are running in the background, you can grab your most recent scans that are part of that scan set, look at those accordingly. But in this case, I just picked a few random scans just to kind of show you the different functionalities we have. You have your scan IDs listed here that are shown and color coded. I've got my various metrics showing full width, half max, center, my edges, my penumbra widths, etc., as well as my flatness and symmetries. So I've got all that functionality there at your fingertips, showing what filters I'm using. So here I'm normalized at center, and one of these I have I've got a couple boxcar smoothing going on, and those filters are up here. I've got a couple of different smoothing filters. I've got Gaussian and boxcar smoothing. I have the ability to edit a point. If I have like a weird point that for some reason is showing up and I want to edit that, I can do that accordingly. I've got a couple different. Oh, and there's my showing that my 10 by 10 fields are done, so I can go ahead and I can actually go in and start my 5 by 5s. So I'll go ahead and do that. But then we'll jump back to analyze. I've got a couple different, normalize at center. I can normalize to a specific value. I can center my scans. I can do an average symmetric. I can do some mirroring, positive, negative, and negative, positive. I can do a flip, 180-degree flip of the scans. I can do a shift. My depth, I don't have any depths showing, but you can go in there and you can do a dose conversion from your ionization measurement to dose, utilizing the set inner diameter that we put in the detector information. And like I said, it gives you all the different information here. Another nice thing, we've got very easy comparison to scan comparison to reference scans. You can go in and you can set your reference scans. So if you have a reference set that you implemented early on, say maybe your initial your initial beam data that your initial commissioning scans, you can choose those as your reference scans. I can click that. Oh, and now all my scans are done. I don't know if you heard that on your end, but there was an audible ding, kind of like a doorbell, that notifies you that your scans are complete. Sometimes you can hear it, sometimes you can, as I'm doing a webinar, depending on the setting of your computer. But anyway, going back to my reference scans here, you'll see once I do that, I get a scan comparison gamma down here, showing you the gamma comparison to the reference scan for the specific scans. So I've got that. I can set my dose tolerance and my distance to agreement accordingly. It's defaulted at 3%, 3 millimeters, but you can set those accordingly. And then as I go down here, going to my metrics, you can see here that I not only do I have my scans showing that I had before, but I also have a second set or second indicator here showing me that 88, these asterisks note that this is my reference scan, my chosen reference scan. 90 here is showing 2 dashes. That just basically means that there is not a reference scan attached to that I'm seeing right now. And as you go here, you'll see why, because this is an in-plane scan versus everything else is a cross-plane scan. And that's the same with this. They're all 10 centimeter depths, and this is a 5 centimeter depth scan. This is number 394. So that one does not have a reference scan attached to it either. But if there is a reference scan, you'll see here, like scan 91, you'll get your comparative numbers. So how it compares to that reference scan, your center, your edges, your penumbra widths, things like that, your dosimetry percentages at Dmax and your minimum, your flatness, your symmetry comparisons as well. So it just gives you things to compare to that original reference scan. You can always show the raw measurements. So if I have, these are all normalized, so I'll show my raws. There's my raws, my raw measurements before they were normalized. I've got my specific tools for zooming in, things like that, so I can zoom into specific scans. I can move them around, drag them around accordingly to take a look around. I can also zoom in with the zoom in and zoom out buttons. I can always return home. I've got a couple tags where I can tag a single tag as I move across the points, or multiple tags depending on where my settings are. So I have that functionality too. So that's kind of all the visual analysis. And with your metrics down here, your filters, I have a number of different protocols I can select, my APM protocols, my IAC, things like that. So I have those functionalities as well, depending on the metrics that are used. Then I've got these tools up here. I can add scans to my list of scans that I show here. I can clear all the scans. I can save a scan set. So if this is a set I want to save, I can name that, and then I can bring that scan set up accordingly as a single scan set to display. We can do half scans. So if you're doing very large fields and you're only doing a half scan, you can merge those half scans, and then the software will stitch those half scans together to give you a full scan. I can remove filters or clear all my filters. So in this case, if I can remove my last filter, or I can clear my filters. I can look at my scan sets accordingly. I can export. These scans to a number of different types of formats. So if I click on export, I can choose an export type. I have the ability to export it to my various treatment planning systems, Eclipse and Monaco, Electa's Aqua QA management system, Philips Pinnacle, Rayplan from RaySearch. I can do exports to CyberKnife for their precision treatment planning system. Then I have a few other ones. I have the ability to export them to DoseView, as I mentioned, if you're a consulting physicist and you want to move them to, say, a laptop so you can do some analysis offline at home, whatever, not connected to the software at a specific center, things like that. You can export it and import it as a DoseView file. I can export in CSV, so if you want to take a look at your data points specifically, you have that functionality. I can export PDD tables for my PDDs, and I can also convert my PDD tables to TPR tables as well. So we do a calculated TPR, which is pretty straightforward. So that's kind of the different exports that are available. And then I can also import scans. So like I said, I can export them in a DoseView format. I can also import them as a DoseView format. We also do have a tool, a scan import tool, that will allow you to take legacy scans from, say, an IBA system or a PTW system, convert those into DoseView based files, and then you can import your legacy scan data into DoseView as well. And then we also have the different report functionalities also. We have the ability to export to a couple different types. We can export to a CSV report, and we can also do isodose curve PDFs. So you know, it's kind of a gives you the ability to do those reports as well. You can also choose scans to archive. So if I have some older scans that I don't necessarily want to incorporate into my reports or into my my findings, I can you know, archive those as well. But that's kind of a quick overview of the software. I know it's pretty quick, but hopefully you got to see just how quick and easy things are to set up your scan queues, do those scans, set up your measurement components, and run those scans and get the analysis going of those specific scans. I'm going to jump back into my PowerPoint real quick. And just kind of a couple more slides. You know, again, the software summary, easy left to right, top to bottom navigation, fast scan queue setup for easy copy and editing functions. So I don't have to start all my my scan queues from scratch. I can copy those and, you know, change my energy, change my field size, things like that on the fly. Again, no hidden features that you saw. Everything was like readily available at your fingertips. Full export to numerous treatment planning systems. Nice thing about this too is we don't charge for every different treatment planning system. So if you're, you know, a multi manufacturer Linac facility, say you've got an Electa, you've got a Varian, you've got an Ethos, you know, and then you also have, say, a CyberKnife. We don't charge each individual treatment planning system export. You get those all with the system. Everything is turnkey with this with the system for software. We've got that very straightforward post-scan processing and metrics and scan comparisons, everything again at your fingertips. And then lastly, you know, quick hardware summary. One thing I didn't mention is, like, it's a turnkey system, so you get everything. You get you know, in you know, acquisition of our DoseView system, you get the ion chambers, you get the electrometer, all those import export functionalities from the different treatment planning systems. Different protocols, the lift cart, reservoir cart, everything is all included with the package. So you basically, you know, we also have you know, setup and training. So our personnel come on site, uncrate the system, set the system up, and then spend you know, a day and a half with you going through to make sure that you know, get you up and scanning and very easily. So, but as far as the hardware goes, very intuitive and versatile detector alignment system, as I mentioned, gives you pretty quick setup. Once you have the tank filled, you can set it up and have it leveled in 5 to 10 minutes. Structurally rigid design gives you that unparalleled repeatability and accuracy. There's no flexing of the system, so you don't get any cantilevering of the movement of the chamber through the water. You know, everything is precision positional within 0.1 millimeter per axis. We've got the wireless functionality for setup and ease. Excuse me. Gives you that you know, a lot of time-saving capabilities within the system. So it gets you up and scanning and get your scanning going, and then get you kind of you know, moved on from scanning and analysis very quickly. The fast acquisition electrometer with the independent bias, and like I mentioned, it's a turnkey system. There's no additional hidden fees or costs. Everything is all included in the system. So that's kind of you know, just the nuts and bolts and ins and outs and details on our DoseView system. So you know, I want to thank you all. One thing I also like to mention is that we've got a very seamless support system. You know, we're very proud of the way we have customer support. We're very committed to helping resolve any questions or problems you may come across with our products, and that includes not only giving you updated information on things or making things available in our web portal from our website for download upgrades very easily right on our website. Have access to manuals, have access to tech notes, things like that. And then we also have a very strong group. Our customer care group, as we call them, are very responsive. We have phone call, live chats, Zoom calls. We have Teams calls. We have a lot of different ways to that you can access our support group. And like I said, it's a very strong support group, and we get very, very high praise for our customer support. But that's kind of all I have today. I'm going to take a quick peek and see if there's any questions today. I don't see any. I'll stick around a couple minutes to see if anybody does have any questions. If not, if you want to kind of have a kind of more of a personalized overview of the software, we can go through it a little slower. Feel free to contact your distributor or your account representative. Those can be found on our website as well. And we can certainly set up a more personalized, slower walkthrough of the software, slower discussion of the hardware involved, things like that. I'm very happy to do that. So feel free. You can contact us right on our website, standardimaging.com. You can contact sales at standardimaging.com or myself, H. Peterson, at standardimaging.com. And we're very happy to assist you in any way we can. Other than that,
I did see one question come through here.
Oh, okay. Yeah.
They just were asking if you could please give information on how you import results to TPS Eclipse if you have the procedure.
So basically, as far as going to the import into Eclipse, it basically, when you have your scan sets, you select to choose those scan sets and those scans, and it will automatically convert it to the format for the various treatment planning systems. So whether it's Eclipse or whether it's Pinnacle or Monaco, it will automatically convert those to that format for that specifically chosen treatment planning system, and kind of package those all together so you can import those right into the treatment planning system. So it's pretty straightforward as far as the procedure goes. You just pick the treatment planning system you want, and it will import them in that correct format.
Thanks, Hugh. That's all I saw.
So hopefully that answered your question okay. If not, feel free to contact me, and I can, if you have some more specific questions about it, I'm happy to answer those. Other than that, I want to thank everybody very much. I know it went a little long, but I hope it was informational, good information for you, and maybe makes you think about considering a DoseView 3D for your QA needs. Thanks very much for your time. I hope you all have a good rest of your day or evening, depending on where you're located, and I look forward to hearing from anybody that has some questions. Thanks very much.